So the final example asks us to figure out if these two lines are perpendicular to each other. So if we think about what perpendicular lines look like, there are two lines. We can all agree that definitely the direction vectors of the lines would be perpendicular to each other if the lines themselves are perpendicular, because they would hit at 90 degrees right there. But we can actually also look at the normals of each of these lines. Because if the normal of this line and the normal of this red line, they would also be perpendicular to one another if the original two lines are perpendicular. And so because we're given Cartesian form here, it's easiest just to compare the normals. So for the first line, we have a normal, which is 3, 5. The second normal here is 5, -4. And so we're going to figure out if those are perpendicular. And the way we're going to do that is by using the dot product. Because if we dot two vectors and we get back 0, it means the vectors are perpendicular. Okay. But it would be the exact same idea if the lines were parallel. If the lines are parallel, the direction vectors are parallel. If the lines are parallel, the normals would also be parallel. But for us, we care about perpendicular. So all I've done here is I've dotted my two normals. Working out my answer, I get that the dot product was -5, which is not equal to 0. So what that means is it means that the normals are not perpendicular to each other. And is not perpendicular to N2. And so that really means that line 1 is not perpendicular to line 2. And so that is our conclusion. Okay, if you guys have any questions at all, please email your teacher. Otherwise, have a great night.